This video explains how to control process execution timing using the wait signal statement. First, click Geometry in the Import group and import machinebody.sldprt. In the Import Model panel, select only Materials under Include, Collapsed under Feature Tree, and +Z under Up Axis, then click the Import button. Select the Modeling tab. The imported model is collapsed into a single feature, so parts cannot be moved independently using the Interact function. To enable motion for specific parts, split the model. Click Machine Body. In the Component Graph panel, right-click collapsed_0 under Root and select Explode. Its name changes to collapsed_0_1. Expand collapsed_0_1 to see the model split into 50 features. Select collapsed_0_3 and collapsed_0_4 under collapsed_0_1, right-click, and select Extract Link. In the Link Properties panel, set joint type to translational and axis to +X. In Joint Properties, set controller to New Servo Controller, minimum limit to 0, and maximum limit to 550. Select Interact in the Manipulation group. With link_1 selected in the Component Graph panel, you can now drag the corresponding part in the 3D world. Next, let's configure the wait signal statement setting. First, add a signal to the model. With Machine Body selected in the Component Graph panel, click Boolean and Process Executor from Behaviors in the Behavior group. Using the Process Executor allows you to configure process settings for the model. Select the Process tab. Select Processes in the Editor group and click the blue icon on the machine body. Click New Process Routine to add a process and statements. Click Statements. Wait Signal. With Wait Signal selected, in the Statement Properties panel, set Component to Machine Body, Signal to Boolean Signal, Condition to True, and Timeout to 10. This wait signal statement makes execution wait until Boolean signal becomes true. Timeout is the trigger wait time in seconds. If the signal is not received within the timeout, execution proceeds to the next statement. If timeout is set to 0, the process waits indefinitely until the condition is met. Next, add a statement to open and close the part after the signal is received. The Move Joint statement specifies a joint and moves the joint to the target value. Click Statements. Move Joint. In the Statement Properties panel, set Controller to Servo Controller, Joint to J1, and Target Value to 550. This moves the joint when the signal is received. To close the part when the signal is received, copy and paste the wait signal and move joint statements. Select the new wait signal statement. In the Statement Properties panel, set Condition to False. For the new move joint statement, set Target Value to 0. A process has been set up to open and close the part when the signal is received. Go to the Home tab. Connect. Signals, select the machine body, and run the simulation. The machine door opens and closes by switching the Boolean signal between true and false. This concludes the course. Let's make process execution wait until a signal is triggered. Thank you for watching.